Okay, we're now going to do the reverse of this. We're now going to do the reverse. If the graph is given, how do you determine the equation? Grade 11s and 12s, you need to know this. This is what makes up your functions paper. Okay, let's go. Okay, now you open up your paper. Math paper 1, you go to your functions. They don't ask you to sketch. They give you the exponential graph. They give you that graph. There's your exponential graph. They give you this point here, P, X, and Y. They give you another coordinate here, A, minus 2.5. Okay, they now say that the following graph is given by h of x is equal to a to the power x. Find a, or determine the equation. Find the equation. Find the equation of the above graph. Find the equation. Answer. Right? That's your question. That's what appears in the exam. You now need to give the answer. So you've already got, now this P, X and Y, they might ask you, question number 1, find the coordinates of P, X and Y. They love asking this question, and it's only worth 1 mark, guys. It's only 1. It's a no-brainer. You don't need to think about it. We know that both exponential graphs only went through one y-intercept, 0 and 1. Why? Why is it 0 and 1? Because from exponents we know whenever the base, no matter what the base is, whenever x is 0, any base to the power 0, whenever x is 0, y will always be 1, because any base to the power 0 is always 1. So therefore that point of intersection will always be 0 and 1 for a standard exponential. Not for an exponential with a shift in asymptotes. For a standard exponential, that point of intersection will always be 0 and 1. Now, let's find the, now determine the equation. Right? Find the equation. And that's worth 4 marks. Okay, so all we do now is we say y is equal to its exponential, so a to the power x. Which alphabet are we looking for? A, obviously. Right, so now we got x, we got y. So what is y? Half is equal to a to the power negative 2. So now we know a half is equal to 1 over a squared. So now it's an equation. If I flip this side, I can flip that side. So a squared over 1 is equal to 2. So a is equal to the square root of 2, plus or minus the square root of 2. But we know this is a positive graph. We know this is a positive graph, so a must be positive square root of 2. Your final equation is h of x is equal to root 2 to the power x. And there we go. That's your a value, a to the power x. And why is it positive? Because it's a positive graph. Okay? There we go. Only one template. Guys, if you know this template, you can do them all. Now let's do the theory questions that will probably comprise of about 10 to 12 marks that will be based on this exponential graph. Okay? So let's take out your pen and paper, or open up a new page, brand new page, put the heading Theory for Exponential Functions. Let's go now on to the theory. Now, I want you to understand something. Pay attention. We had two graphs when we initially sketched the graph. We had the positive graph here going through 0 and 1. And we had the negative graph going in that direction, also going through the same point 0 and 1. That was my x, that's 0, that's 0, that's my x-axis, that's my y-axis. Right, what's common? What's similar between the two functions? So here are your theory. So now you can write this down. All standard exponential graphs. All standard exponential graphs. Number 1, what's similar between the two? Have only one x-intercept or y-intercept? Y-intercept. And what is it? 0 and 1. Always. So that's your theory that you need to learn. Number 2, your x-axis. Your x-axis is your asymptote. And what is the equation of your x-axis? Y equals 0. A positive graph is known as an increasing function. They might ask you, is graph H increasing or decreasing? You look whether it's in what direction is it going. If it's going in that direction, it's increasing. If it's going in the opposite direction, it's a decreasing function. So a positive graph is an increasing function, and a negative graph is a decreasing function. What is the domain for both graphs? The domain x is an element of real numbers, because any x value here will give you a corresponding y value on the graph. So x is an element of real numbers. What is the range? The y values. Now, no negative y values will ever touch this graph. 0 will never touch the graph. So all your y values above 0, all your positive y values will give you corresponding x values. So you're going to say y greater than 0, not equal to, y greater than 0, y is an element of real numbers. Or you can say, another way in which you can write it in interval notation from 0 to positive infinity. 0 excluded, so we put a round bracket. Infinity is always excluded, so we put you never say including infinity. Right? So there we go. That's your domain. So all standard exponential graph guys quickly have only one y-intercept, 0 and 1. Okay? Your x-axis is your asymptote. The equation of your x-axis, y equals 0. Positive graph, increasing function. Negative graph, decreasing function. Okay, your domain for both graphs, x is an element of real numbers, your range from 0 to positive infinity, or y greater than 0, y is an element of real numbers.